This is the solution to number 2 on the 2013 exam. So we have a particle moving on a straight line. We're given a domain of 0 to 5, our velocity function, and the position is called s of t, and they give us this nice little initial condition here. For part A, we're asked to find all values in this interval for which the speed of the particle is 2. Now remember that the absolute value of velocity is equal to speed. So if we want to know when speed is 2, we want to see where v of t is equal to 2, or where v of t would be equal to negative 2. And we're just going to use our calculator to find those values. We're going to graph v of t as our y1, and then 2 as our y2, see where they intersect. And then do the same thing with v of t and negative 2. And those values should turn out to be 3.128, or it could be 3.127, depending on your rounding. And the other place is 3.473. For part B, we have to write an expression using an integral that gives us position. Okay, so position is the integral of velocity. So we would integrate velocity from 0 to some time t. I'm going to change my variable here. You can use anything. I'm going to use x. But this here is representing a constant, so we don't want t over here as well. So it's v of x dx. But also plus 10, because our initial position, as they told us in the directions up here, our initial position is equal to 10. All right, second part of part B says to use the expression to find the position of the particle at time t equals 5. So we're looking for s of 5. Now let's say if you had trouble finding this expression, then you would have trouble finding this. What you want to do is make up anything. Just have some expression here that you can use to substitute 5. Depending on what your expression is, you may get some credit. So s of 5 is going to look like this. We're integrating v of x and adding 10. And again, this is a calculator question, so we're going to put all of this right in the calc, and we get negative 9.207 as our answer for part B. Part C, we're looking at when the particle changes direction on our interval. So we want to find out where our critical numbers are, so that's where v of t is equal to 0. So we look for that solution on the calculator, and we're going to get two places. There's this 0.536 and a 3.177, and so on. So you can take a look at your velocity graph, and you're going to see that v of t does change sign at these two values. So we'll say, therefore, the particle changes direction at these two places. Okay, part D is the speed of the particle increasing or decreasing at t equals 4. So this is where we want to know if our particle is speeding up or slowing down. So we need to look at velocity and at acceleration, which is our derivative of velocity. And again, We're using the calculator. We're plugging 4 right into our given velocity function, and we get this number, which is negative. For the acceleration, you can take the derivative by hand, but it is okay to use your calculator. If you go to Math and choose number 8, that will give you an option to calculate a derivative at your point. And that should turn out to be negative 22.296-ish, which is also negative. So since the sign of velocity and the sign of acceleration are the same, they're both negative, our particle must be speeding up. So we'll say the speed is increasing because V of 4 is negative and A of 4 is negative.